Let's talk about AI. I was thinking maybe I should tell you what is AI, although probably you all know what is AI. And as you probably also know, there are many, many definitions about AI. We always use this one because the focus is so much on knowledge and on intelligence. So it says that AI are machines that can perform cognitive processes like learning, interacting, and problem solving. And for that reason, we think that this definition is relevant because it also assumes that the things that we humans are very good at, and we're trained at, and we have learned that for years, machines can do that better. At least that is the promise. So AI systems are different from the expert systems that were introduced like 20, 30 years ago, because these systems focused on rather simple tasks, while the AI systems of today look at complex intelligence tasks. For example, systems that are able to spot whether an art is real or not. Humans can do that. They train to do that. They learn that for 20, 30 years, and they're very good at that. And now suddenly machines can do that better. That's what they say. And so we have so many other applications that seem to be better than humans, and that's why we are there. We study if that's really true. Okay, the first question, if you think about AI and work, is will AI take over our jobs? Are we going to enter a society where there's unemployment? Who is still thinking this? I think we passed that. You? Oh, man. Giovanna. The organizer of this event. I think we passed this, this first hype. AI is not going to take over our jobs. There are several reasons why. I can give you some. First, what people like Brynjolfsson, who started this discussion 20 years ago, or sorry, 5 or 10 years ago, he did this analysis based on the existing jobs. Honestly, it wasn't him, there were people at Oxford who did that. They analyzed the existing jobs, and then they calculated that many of these jobs, maybe even 90% of these jobs, will not exist anymore in the future. But, and then there was Brynjolfsson, he said a couple of years later, you used the wrong unit of analysis. You should have used tasks, so really the tiny aspect. And if you analyze the tasks, so people have like 20 or 30 different tasks in their job on average. If you analyze the task, then things are completely different. And then we might even get new jobs. Another reason why we will not end in unemployment is that we need a lot of new jobs. Nice jobs, like the data scientist, AI auditors, interpreters. I will talk about that later also. Also not so nice jobs like taggers. There is a tagger in the room. These jobs are really not nice, but they are needed to develop databases, and they're needed to feed the algorithms. These people work in factories, the tagging factories, and it's a terrible job. But I need to mention them as well. The bad side of AI. Also, we will not enter in a society where jobs are not needed because we only have narrow AI. This idea of general AI is really future thinking. We're not there yet. It's the small AI. Even though the small AI is very small, when they are introduced in organizations, they really can change organizations. They have the power to reorganize organizations. I will discuss that later as well. And then, of course, not all human capabilities can be automated. Think about emotional work. And then, final reason, or one of the final reasons, is that we, in the future, will have a lot of unemployment, or a need for employment because of, for example, the older generation and unemployment because of that. So we don't have to be scared about AI for that reason. There are different perspectives on AI and work. The one that I just showed you and we just talked about is the perspective that I would call the labor perspective. That perspective is studying AI with the question, are we losing jobs? Are we losing tasks? What new tasks are needed? It's very much data-driven research, a lot of analytics. It's a field of research that is specifically done by economics and labor economics. Robert Siemens, he will be here tomorrow. He has a very nice paper on that. I really advise you to read that paper. It's a nice paper. It's specifically from the perspective of labor economics. Then we have another perspective, that what I call the critical perspective. And these people are looking at why, when, how does AI result in, for example, profiling, inscription, in statistical biases, in discrimination, and how can we avoid that? I think that Meredith prepared a talk within this stream of research. Also, of course, very much needed. Unfortunately, these perspectives do not really talk to each other. They're very independent, they're silos. This is also the reason why we have this conference. And another perspective is the business and strategy perspective, where people are studying whether AI will help the business. Will it gain management, stakeholders, value? Again, a separate perspective. So 3 perspectives that are fine, but they don't talk to each other. That's one problem. Another problem is that they do not really go into the field. They do not study what is really happening. And there are reasons why they don't do that. It's not that easy to get access to organizations. But we need to do it, I think. At least this is our agenda. So this is what we do at the AI at Work lab. We call it a lab because that gives us more legitimation among the computer scientists. We are, of course, not a lab. We're not making anything. But we are a hub of researchers studying AI, and we're using what we call the socio-technical perspective. So we go into the field, and we study the designers, we study the users, we study management, and we have these questions. So the question how to study it, we are using ethnographies mainly, and process research. So we are not there for a snapshot. We go there, and we're there for like sometimes even 3 years. I have a PhD, Lauren, sitting here in front. She couldn't stop doing research anymore. She studied the police and was addicted to the police, was our really. This is what you get if you do ethnography. You're so much embedded in the field. But with doing ethnographies, you really see how people are developing systems, how they are using it. And we study multiple stakeholders. So the who question is answered by looking at different stakeholders. And what is also important is that we are starting our analysis already at the start of the journey. So AI is on a journey, is something what we often say. It's already happening. It's now learning, it's failing, and it's learning again from this failing. And we need to be there because it makes a lot of mistakes. And sometimes it's also not very desirable, these systems. So we need to be there. We need to learn from it. And why are we studying it? It's because we want to go beyond the hype. It's also a slogan that we have at KIN, looking beyond the hype. This is to have a sort of advantage in comparison to the consultancies. But it's also true, because we are academics, so there's no reason to be biased, and there's no reason to sell anything. You see several images. These are the 6 PhD topics at the moment happening. Above, you see the radiology case. We are studying how AI is changing radiology. As you know, some people say that radiologists are the professions that will disappear the first. What we see is this is not happening at all. Radiologists are actually very happy with the systems because they can give a lot of routine work to the system, and they can focus on the more complex diagnosis. You see a picture of video analysis of candidates. So we're also studying HR. I will talk about it a little bit more. This is a heat map at the police that we're studying. We're also studying chatbots. We're studying AI in the biotech. And we study the Phi robot at Philadelphia. These three are just starting. So if I have time, I will talk about these three in more detail. The first one, this is a research that Elmira van der Broek, she's also sitting in front, one of our PhD students. She is already doing this for a couple of years, studying the use of AI to select job candidates. She's doing that at a large international organization and also studying how these systems are developed. So there is a vendor, AI vendor, who's developing these systems based in the UK. Elmira is also studying how they are developing these systems. What is very interesting of this case, there are several things interesting. Of course, the whole aspect of fairness. I'm not going to talk about that, but it's very important. We're working on a paper there as well. But what is also interesting is how these people are developing these systems. Because what people have been thinking is that with self-learning systems, the machine learning systems, we do not need the domain expert anymore. We can rely on all the data. And the data itself will bring enough information for the system to learn and to improve. So when going in the field and talking to these people, seeing how they're developing these systems, we see that they slowly become more and more dependent on the domain expert. They cannot just do that independent from them. In fact, they become even more dependent than software houses in general. They need to ask them to fill in the right data. They need to be there to correct the data. They need to be sure that there won't be making any mistakes in the data, that the algorithms are correct. But also, the outcomes of these systems are sometimes not what the client wants, even though the system is very objective. I should tell you that the system is based on both games and video analysis of candidates, but specifically games, right? So candidates fill in games, and then with the games, you can analyze the personal traits of people. And based on the profile that the company gives you, the system is learning and becomes better in selecting candidates based on these personal traits. There's a lot to say about that. And also in the organization is learning from failures also, and they learn that the system gives advices about candidates based on objective measures, but these candidates, they actually would never have selected. So they also learn. Should we use this system? Should we be more involved in developing these systems? Well, this is correct, Amira. Always difficult because an ethnographer knows so much more than I do. Okay, another example is the case of predictive policing. How many minutes do I have? 10. This study is done by Lauren Waardenburg, also sitting in front as a PhD student. She studies how the police in the Netherlands is using data based on criminal activity in the past, where, for example, burglars were active, where and when, so location-based and also time-based. And based on that information, the system learns. So it's a learning system, and it comes up with heat maps. You see that on top. That's a heat map. So the dark parts, the red parts, are the spots where burglary happens, right? I'm looking at the developer here. So this system is introduced in the police already a couple of years ago. It's used by all officers in the Netherlands. But what we saw while we were there is that the system itself is not enough. for management to really make decisions, and specifically work allocation decisions, so when to send an officer to a particular potential crime accident or whatever, what have you, they needed to have an intermediary in between the system and management. So you see this person, the intermediary, sitting here. They call the intelligence officers, and they help the police as well as the designers to better align the system with the practice. This is something that came up during the journey of the AI. So the organization learned from that. They learned that they had to have an intermediary in between the system and management. Interesting enough, but it's a long, long story, these intelligence officers acted as curators. They started to make the system better and also came up with their own predictions, which is interesting because the management doesn't really mind, and they make their decisions now based on what the curators think is important more than what the system says. So this case shows also that it's important to have a multi-stakeholder approach. So not only looking at, for example, the police officers, but take the whole ecosystem with you. So we analyzed the data scientists, how they managed or how they modeled the system. And based on the heat map that they developed, we also saw that we needed intelligence officers in between the system and management in order to give better prognosis. And also when we were studying management, we saw that they needed to have information from the intelligence officers to do their work allocation practices better. So the whole ecosystem is important, and they influence each other. Of course, we are talking about this also a self-learning system, and it has its downsides, but it's important to take that into account, that you have different actors involved. And this case also shows the importance of the intelligence officers as curators. Oh, I still have this. Just this is not really AI, but I included this slide because it also shows the importance of looking at knowledge not as only in the individual brains, as individual cognitions, but something that is also practiced, that is social, that is distributed. And if you look at knowledge from that perspective, you can also understand why introducing AI systems always influences the whole organization, or at least a team of people connected to each other. For example, I don't know if Anastasia is in the room. No, she's teaching, I think. Anastasia Sajiva is the researcher who did this research. She was studying how the Da Vinci robot, you probably all know the Da Vinci robot, was introduced in an operation room and how this influenced the whole work activity. You would have expected that this would change the work of the surgeon only. So you study, if you have this perspective of individual expertise, you study how this surgeon is changing his or her work. But because we have this socio-technical perspective, thinking about knowledge as distributed, we included the whole OR team. And we saw that it wasn't not only the surgeon who changed, the surgeon because of the Da Vinci robot. I don't know if I should tell you a little bit. The Da Vinci robot asks you to sit in the corner of the room with your head in a console, being completely immersed in a 3D environment, and then operating the patient. The patient is somewhere else. So the nurse is close to the patient in order to, for example, cut open the patient, but also stitch the patient. The anesthesiologist is also there, but it has another duty now because a lot of dangers can happen now with the Da Vinci robot because the arms, you have 9 or 8 arms above the patient, and it can clash the patient. So there's the anesthesiologist having to have another task or another duty, making sure that nothing happens with the patient. So you see all different constellations and a whole different OR team because of the introduction of the Da Vinci robot that was actually only meant for the OR surgeon to help with his or her work. A long story. So this is what we call ripple effects. Ripple effects are very important to study. It's not only just one person using AI systems. If this person is using it, it has ripple effects for the rest of the team or even for organizations. All right, so we come to the implications. So there are, of course, implications for researchers, as you can imagine. As I said, AI is already on its way. It's off to work. And we need to be there as researchers. We cannot wait anymore. We cannot stick to the predictions and to the survey-based analysis. We need to be in the field and study the field. And of course, when you study the front runners, as we do, you also see a lot of failures. And for them, they learn from these failures, of course. You know, they want to have nice systems as well. They're not the bad guys. And they do that by negotiation, by interacting with the developers. And all these things, all these activities that are happening in the field are important for us to study, also to give that to the next person, the next organization that wants to enter AI. And what is also important is, of course, to study AI from a multidisciplinary perspective. Don't only look at the impact of AI on people using it. Look at the managers, the decision makers, but also look at the designers. And finally, see AI as a reorganization. Because knowledge is distributed, because knowledge is shared in practice, and it's negotiated, oftentimes introduction of smart machines means a reorganization. For example, introducing a new role of intermediaries. And, well, this conference is a multi-stakeholder conference, of course, which I, by the way, really, really like. Should happen only. And usually I go to conferences as an academic conference, and we have all my friends, and it's beautiful and nice. But no one is reading our papers except for the academics and my mother. Is also still reading my papers. But no one else, and this really should change. I'm so happy that Giovanna is doing this work, because it's really needed. Anyway, so implications for other stakeholders. Of course, for the developers, it's very important to collaborate with the domain, the knowledge domain, to understand what these people are doing in practice, and that their knowledge is not individually cognitions and brained, it's shared. And introducing AI, and we see it at every organization, means a reorganization. It's good for developers to know that, and also to see AI as a journey, learning, failing, learning again, and it's a cycle of augmentation and automation, a continuous cycle. An implication for management is, of course, to focus on organizational change, not only on the individual. Stay informed and educated. That's extremely important. Managers need to come to lifelong learning courses of whatever you have. We at Kin also offer these courses to know what it means, for example, to have white spots, or, well, what does it mean if you have biases in your data, or actually what does AI mean? And do we need AI? All these questions are important. So stay informed and educated. And for policymakers specifically, I would say one of our recommendations is that people need, as I said, more technical skills. Everyone. Kids can do it, but you know, my age people are really bad at it. We need to educate people. But also these tech people, people studying AI, they also need to have more social skills. They need to know that the domain for which they are developing systems are very important to understand. All right, so this was my talk. And now I want you all to become a member of KIN. That is possible by joining us as a network partner, and I'm not going to discuss that further. I'm just going to end this discussion with thank you for listening to me.